Okay, well, we've got a problem here, another statics problem. So let's draw a little diagram here. We've got a ground. Let's just flip colors here. And we've got a pole. And we have a kind of a pin connector and another pole that goes up like this. And we have a cable that goes from this point horizontally till this point and holds on. And at the top here, we have a rope that's hanging down and holding a mass. Okay? So like a kind of like a almost like a crane type of a situation. Now we're going to call this point A, point B, and point C, and we're going to call this point D. And we're going to give you some lengths as well. Let's say that this length here is, let's make the lengths in this color. This is 4.8 meters. Okay. And let's also make this length here to be 0.9 meters. Okay. And let's make the mass of this rod, or mass of beam, equal to, let's make it 6 kilos. Now, we're also going to say that this mass here, the mass of the weight of the box, is equal to, let's say it's 12 kilos. Okay, so that's double. Now, the question here is, what is going to be the tension? So let's put this in red. Find the force of tension in this cable. Okay. So, I mean, if it makes any better, this here from D to B is a cable, but from A, B, C is not a cable. A, B, C is actually a beam. Okay? And the other thing which we need to figure out is what are the reaction forces at point A. So let's call this FAY, and we'll call this FAX. So we need to find FT, and we also need to find FAY and, I should say, and FAX. How are we going to do this? Well, let's put the other forces in. Obviously, this is a cable here, dB. So this force is going to pull that way. That's Ft. There's going to be a force here which is equal to the weight of the box pulling down, mg, mb, as it B for box. And there's also going to be another force as well, right about here, right in the middle of the beam. Now, unfortunately, I shouldn't have actually used B because beam and box start with the same letter. So we'll call this, how about rod mass? And we'll call this MRG. And by the way, the distance, is halfway. So this distance is going to be 2.4, half of 4.8. Okay? Now, we've got 3 equations to solve this problem. We need to find 3 things. 1, 2, 3. And we have 3 equations to do it. We have summation of the forces in the x direction must equal 0. Now, how many forces do we have in the x direction? How many forces do we have in total? 1, 2, 3, 4, 5. And the only 2 that are horizontal are FAX and FT. That means that FAX minus FT must equal 0. Okay? So obviously we know, therefore, that FAX has got to equal FT. That's good to know. Now, if we continue and we say, all right, well, what about the summation of the forces in the y direction? Here, let me do that over here. Let's get rid of this for a second, because I can do that probably over, fit it in over here. Now, in that case, we've got FAY minus MRG and minus MBG. So I've got FAY minus MRG minus MBG. That's all going to equal 0. And by the way, I know the mass of the rod and I know the mass of the box. So I can actually find FAY now. So let's go ahead and do that. So FAY is going to be equal to, we can actually take both these terms, put them on the other side, they become plus, and we can even factor out a G. So there it is, and we're going to get 6 plus 12 kilograms times G, and that's going to give us 18, enter 9.8 times, and we're getting 176.4 newtons. Okay, so now at least we've got 1 down, 2 to go. Okay, so we're done with this one. We've got two more to go. At this point, what I would do is I would decide to take the sum of the moments about a certain point. Now, because I have 2 unknowns, my unknowns here are FTY and FAX. So I have to make a decision as to where I'm going to take the sum of the moments about. And here is a summation symbol, so I can say summation of the torques about what point? Well, if I pick point B here, I get rid of FTY. If I pick point A, I get rid of FAX and FAY. So personally, I think it's probably going to be less work to pick point A. So I'm going to say, all right, take the summation of the moments about point A, and they should all sum up to 0. So at this point, we can ignore FAY and FAX. But we've got 1, 2, 3 other forces to deal with. And if you'll notice, none of them, MRG, FT, and MBG, none of these guys are actually perpendicular to the distance from point A to where they're located. Hence, I'm going to use my technique of drawing a dotted line through my forces there, there, and there. And now I can simply move MRG down to here along its line of action. I can move MBG down to here. And why down to here? Because I want to get to the same height as point A. I can move it down to here, where I can now use that as MBG. So I've got MBG here, MRG here, and why don't I do the same thing for FT here, which puts him right there, acting that way, and that's FT. Now, let's go ahead and take the sum of the moments. Now, this one here, let's use gray for this. MRG is going to, about this point A, it's going to cause a clockwise rotation. MBG, clockwise rotation. Therefore, they're both negative. So, if I pull it up here and I say, okay, negative MRG multiplied by the distance. What is the distance? Now, there's one thing I haven't given you, and I apologize for not giving this to you earlier in the problem. I actually forgot to write this down. But this angle here is 50 degrees. Okay? So, if that angle is 50 degrees, then if you use the concept of alternate interior, this angle is 50 degrees. And if that angle and this angle are both 50 degrees, then how do I get this distance from here to here? Well, that distance is simply 2.4 cosine 50. So let's put that in. 2.4 cosine 50 minus, now this guy, MBG. Now, instead of it being 2.4, now the whole distance all the way to the top here is 4.8. But this distance now is going to be 4.8 cosine 50. Then, the only other force that I have left is FT. And FT is acting right here, which is given in the problem as being 0.9 meters away. So I would say plus FT times 0.9 meters, and that's all going to equal 0 because there's 3 forces. As you can see now, I can solve for FT. And FT is going to be equal to positive MRG times 2.4 cosine 50 plus MBG times 4.8 cosine 50. Okay, and that's going to all be divided by 0.9. And let's see what we get. MR is, mass of the rod, is 6 kilos times 9.8 newtons per kilo times 2.4 cosine 50 meters plus 12 kilos multiplied by 9.8 newtons per kilo multiplied by 4.8 cosine 50 meters all over 0.9 meters. So now all we need to do is get our calculator out, our trusty RPN, and here we go. 6 enter 9.8 times 2.4 times 50 cosine times 12 enter 9.8 times 4.8 times 50 cosine times plus 0.9 divided by, and I get an answer of 500 approximately 503.9 newtons, 504 newtons. Now, we're pretty much done at this point, because if you remember, way at the top, we said right here that FAX is equal to FTY in the opposite direction. So therefore, FAX is also equal to 504 newtons. And so we've got these two guys, and the other one which we got was FAY here. And we're done the problem. Well, thanks for watching.